have dealt with translations, transformations, right, left, up, and down in junior high. We moved stuff, right? Reflections for us are all going to be reflected in the x-axis. So whatever's above the x-axis will be below, or whatever's below will be above now. Or a reflection in the y-axis, okay? So if we have a reflection in the x-axis, that could be also noted as a reflection in the line what? What's the equation of the x-axis? Make sure your notes are up. What's the equation of the x-axis? What are the values of y on the x-axis? 0. Every y value on the x-axis is 0, correct? And horizontal lines are y equals lines, and vertical lines are x equals lines. So the equation of the x-axis is actually the line y equals 0. Y equals 0 is the x-axis. So we're comparing y equals f of x and y equals negative f of x. So, can you guys type this into your calculator, please? X squared minus 4x plus 4. Then we're going to sketch it. So, reminding ourselves this is on a computer that doesn't show blue boxes, but it does not have the calculator, or I can use a computer with blue boxes, but it has a calculator. It's really a conundrum, so I'm not going to have the calculator on this one. But when you type this one into your calculator, you get a quadratic, correct? And quadratics are from grade 11. Now, can we just pull the minimum instantly off the calculator? Often not. This one looks like it's probably at 2.0. But let's practice finding our minimums anyways to remind ourselves. So everyone goes second trace minimum. Second trace minimum. Then what does it say? Left bound. So we need to be on the left side of whatever we're finding. And we're finding the minimum, correct? So go to the left side of the minimum and hit enter. Then what does it say? Right bound. So now we need to be on the right side of the minimum and hit enter. And then it says guess. Just press enter. You make it guess. It's weird. I don't know why. And we get, now on my screen, just so you know, my screen says 1.9999987, which is 2. But my y value actually says 1.6 e to the negative 12. E to the negative anything is just scientific notation for 0. So if I have e to the negative 12, I have 0.000000000000000016. I may have lost count of a 0. But we round that to 0, okay? So if ever you see on your calculator, did you guys get e's or did you get zeros? So if you get e's, you can see the e I have, e to the negative. That is a fancy way of saying 0. So if you get e to the negative anything like that, if you didn't get it, you got 0. E to the negative. If you get e to the negative anything, everyone looking? You see my e? Yours is 2 0. You just need to get e to the negative. Yours is good. You can, sometimes you get 2, and sometimes you get 2. Or sometimes you get 0, sometimes you get 2 rounds. That's 0.
I got 1.99999.
So that's 0 decimal 0 0 0 0 0 0 0 0 0 0 and around that, right? So if it's e to the negative anything, you see that? I don't know if you guys got it. E to the negative, you see that? Oh, damn. That's second. Oh, mainstream.
Yeah, I got 1.99997.
it has a negative on it, right? And the negative? Negative?
Did you push second trace? Did you? Oh, there you go. I just think X squared minus 4X was.
Yeah, this is exactly the point. So that's 2 and 0. Right?
Yeah.
So draw your minimum at 2, 0, please. Now you have to put it in your left pocket. Left pocket, and then it's made you feel so good. After the left pocket, it makes the bookshelf. It's a crazy thing. It like slowly works its way to the bookshelf.
So if I put it in like my back pocket,
No,
then
you don't
has
get
to
to
go to the right
you don't get to go back pocket, right pocket, left pocket, bookshelf. No, you don't get to work. You don't get to work through more pockets. That is not how it works. Okay. 2, 0. Put down 2, 0. Now I'm going to show you how you can get the other ones. So can you guys go second, trace, value. Now you can put in any x value and it will kick out any y value. So put in number 1, enter. It gives me 1, 1, right? I don't have to redo it. I just go 0, enter now. Go 0, enter. What does it give me? 4. And then I go -1, enter. And I get 9. Can I put in decimals in there too? Let's try it out. Go 1.5, 1.5, enter. It's at 0.25. So at 1.5, I'm at 0.25. So it's like down here, right? So you can get as many x's as you want. And then you don't have to go to the table of values, which is limiting. I'm going to put in 3, and I get 1. 4, enter, and I get 4. 5, enter, and I get 9. So we have our graph, correct? Yeah.
So this thing is just going second.
Yeah, that'll get you the main ones, but it won't get you decimals, right? So sometimes on your table, it'll go like 0, then it'll go 9, and then it goes 25, and you don't have enough points.
Yeah.
So you might have to put in like 1.2 to get a point that lands on your graph. Yeah, so the second trace value one just means you can put in any value. 1.6, 1.3, 1.2, you know what I mean? Okay. We know that this reflects in the x-axis, right? That's what we're doing right now. We're reflecting it in the x-axis. So your x-axis is actually your mirror, correct? So if anything is on the mirror, it stays. Has anyone put a toothbrush up to a mirror before? I say this, and I feel like I'm the only one. Try it out. Okay? Remember the kid went like this to just see what it would, see what the toothbrush would do? No? Okay, guys, I didn't have cell phones. We had to find things to do. I put a toothbrush against it, hairbrush, finger, nothing. Tough. All right. This is what cell phones has done. You guys don't even think to put a toothbrush against a mirror. Shame. Shame on the cell phones. All right. So where the mirror is, it's staying. Okay? So if this is my x-axis and I reflect on it, this is going to stay here, correct? This point at 1, 1 is going to become 1, -1. Do you see how it's reflecting it down? 1, -1. This one at 3, 1 is going to become 3, -1. So let's think about that. 1, 1 is going to become 1, -1. 3, 1 is going to become 3, -1. Do you see that? Pay attention. So our mapping would be x, y becomes what? Did our x change? X -y. So when we have a reflection in the x-axis, anything above the x-axis is going to go below, and anything below the x-axis is going to come above. Does that mean it's shifting right or left at all? No, it's just going to be up, down, down, up, correct? So my negative y's will become positive y's, and my positive y's will become negative y's. So it's actually your y's that negate when it is reflected in the x-axis. So when we say reflection in the x-axis, or in the line y equals 0, it actually affects the y values. So it always affects the opposite of what you think. So if it's reflecting in the x-axis, it affects the y values. The y values are negated. Okay? So that's going to be our mapping. xy becomes x negative y. So if we do the rest, 0, 4 is going to become 0, negative 4. Negative 1, 9 is going to become negative 1, negative 9. 4, 4 is 4, negative 4. Sorry, 5, 9 is going to become 5, negative 9. So we actually get this reflection image in the x-axis. We agree? So whenever it's a reflection in the x-axis, this will be your mapping. And if you want, you can write this up here to help yourself out. Reflection in the x-axis, your mapping will always be x, y becomes x, comma, negative y. So are the x's being negated or the y's? The y's are being negated, correct? So in our equation, we're actually going to negate the y's. So let's look at this one here. We have y equals x squared minus 4x plus 4. True? I just said we negated the y's to make it reflect in the x-axis, right? So let's do that. I changed my color. I'm going to negate the y. Is that true? But what do we always want the equation in? Y equals. So how do we get that negative y now to become a positive y? We could either add the y over and move everything over to this side, correct? We could do that. That's absolutely true. Or what could we do? Divide by negative 1 every term. So we would divide this by negative 1, this by negative 1, this by negative 1, this by negative 1. So we get y equals negative x squared plus 4x minus 4. Now think about that. That makes sense, because if I had to move the y over to make it positive, I would move every single one of these terms to the other side, and it would just change their sign, right? Which is essentially what we did when we divided by negative 1. Now type this into your y2. Hopefully we're getting the red graph. Hopefully we're getting the reflective one. You definitely are old school. You know that those calculators came out in 2000?
Yeah, that seems like from like
No, they came out before 2000, 1998.
it was like 98.
Well, when I was in grade 10, that was the first year that, yeah. So when I was in grade 10, the calculators, that was the first year the calculators came out in Saskatchewan. So I was the first year of those calculators in my high school.
How much were they? This is the 1999 version. This one's newer than that. So this one's dead, so I don't use it. But yeah, this is
Option.
this is pretty new.
Yeah, my old one actually broke. I think it was $80. It still wasn't cheap. In those times, it might actually be more than the one that we use. It's not cheap. Okay.
Whoa.
99. Okay. Shh. So did you guys get it to show up? Everyone got to show up? Okay, state the coordinates of the invariant points. This is something we have to talk about. Invariant points are very important because they're asked about all the time. They're the coordinates or the points that do not move or that do not change. You will be asked about invariant points, okay guys? They are the coordinates that do not change. So on this graph, what's the only coordinate that did not change? Yeah, the y equals 0, 1. So the 2, 0, right? The 2, 0 is the only one that did not change. Guys, why didn't it change? It didn't change because if I had taken my toothbrush and put it against the mirror, that's the part that's on the mirror not changing. You guys don't know what I'm talking about. Maybe take your Snapchat phone and put it on there so you can read your Snapchatting things backwards. I don't know. Okay, but trust that if you put a toothbrush there, it will reflect. There's a little bit of a gap depending on how thick the mirror is. Okay, so that's one reason. But the real reason is, guys paying attention, your mapping is x, y becomes x negative y. True? The only number that will not change if I take the negative of it is 0. Right? So 2, 0 will stay the same. Paying attention. All right. So, how does the graph, guys? So this is negating the y. You can put the negative here, right? Or you could move it over by dividing it and put it here. Those mean the same thing. Do you see that? That's not with the x. Some people are like, it's with the x. The x is here. She don't look like she's with the x, right? It's with the y. So unless it's in the bracket with the x, it does not affect the x. So this is on the outside. It makes my y's all negated. And when my y's are negated, I have a reflection in the what? In the x-axis. Because remember, your positive y's become negative and your negative y's become positive, therefore reflecting in that x-axis. Right? Understand. We need to understand why we do what we do. 95, can you put that away?
Yeah.
Thanks. Oh, 93. Sorry, I've confused the two of you. All right. So we're sketching a graph, which means we're moving coordinates. When we move coordinates, what do we use? Starts with an M. Mapping. So when we move coordinates, we use mapping. We agree? Okay. So this is negative. Is this negative with the y or with the x? Reminding yourself that this is where the x is. So it's with the y. Unless in that bracket, she ain't with the x. Okay? So my mapping is going to be xy becomes x comma negative y. True? So unless it's in that bracket with that x, in mapping it will affect the y's. In words, it will affect the y's. Okay? So let's move some coordinates. I'm going to take this one, which I'm going to say is negative 4, 0. And it's going to become negative 4, comma, negative 0. Is that even such a thing? Negative 4, 0. What does it say? Negative 4, 0. It's invariant. Why is it invariant? It's on the reflection line, correct? If you're only reflecting, wherever you're reflecting, that's where it stays the same. Like putting the toothbrush into the mirror. The end stays the same, the rest of the toothbrush is reflected in the mirror. Or your phone, if you choose to use that instead. I'll leave you figure that out. All right. This one is 1, and then I'm going to keep going. So then this one is negative 1, 4. It's going to become negative 1, negative 4, which is not invariant. And then we connect our lines. Make sure we're paying attention, guys. And then 1, 0 becomes 1, comma, negative 0, which is not a thing, so it actually remains invariant. So if I was reflecting in just the x-axis, could I go right to the x-axis and just put dots on those dots? Coordinates, like bold the coordinates on the x-axis? Yes, they're going to stay the same. Okay, then we're going to flip over. All right. What's this one doing? Reflecting in the y-axis, which is the same as saying a reflection in the line. What? What do you think the equation of the y-axis is? X equals 0, because on that y-axis, x is equal to 0 everywhere. So sometimes they'll say reflection in the y-axis, and sometimes they'll say reflection in the line x equals 0, which is the y-axis. Okay? The difference now is the negative is with the x, correct? It's the same graph we had before. F of x is the same graph, so we're going to sketch it again. 2, 0, 1, 1, negative 1, 1, 0, 4, 4, 4, negative 1, 9, 5, 9. I don't know why I haven't memorized, but I do. That was good. I'm going to try again. Would you agree? But now instead of it doing this, it's going to do this. Right? So in order to be from here to here, what are we negating? Or from here to here? Our x's or our y's being negated to get it to move right to left. X's, right? Y's, if you're down here, you're going to be up here. That's on the x-axis. X's is this way. We also know it's x's because look at this. The negative is where? With the x. So if I go to do my mapping, it's going to be xy becomes negative x comma y. So anything in the bracket with the x affects the x in mapping. Anything not inside the bracket with the x affects the y's, right? So let's try this one out. So I have negative 1, 9 is going to become 1 comma 9. It's minus a minus. Then 0, 4 is going to become 0, 4. It's not changing. Well, it'll be negative 0, 4. But weird, this one stayed the same because what is it? It's invariant and it's on the line that we're reflecting on, correct? That's like the mirror, like we were talking about. So down here, I'm just going to put this. I'm going to go 0, 4 because it stayed the same, right? Then we have 1, 1. It's going to become negative 1, 1. Then we have 2, 0. It's going to become negative 2, 0. 3, 1. It's going to become negative 3, 1. And then 4, 4. It's going to become negative 4, 4. And 5, 9 is going to become negative 5, 9. And does that look like it's reflecting in the x-axis? And by x, I mean y? Y-axis? Yeah. That would be that mirror, right? Now, we have to do the equation. Remember, when it reflected in the x-axis, it made my y's negative. We agree? But if it reflects in the x-axis, it's going to make my x's negative. Yes? So my equation currently is f of x equals x squared minus 4x plus 4. True statement? Yeah? The last one I made my y negative. I'm going to take this back off. But last time I made my y negative, f of x is just function notation for y, right? I would have made my y negative, and then I would have divided it all over. We agree? But for this one, I'm not making my y's negative. I'm making my x is negative. We agree? So this is going to become f of negative x equals negative x squared minus 4, and then that x is going to become negative x plus 4. See how every x became negative? Do we agree? And then we just have to math it. So f of negative x. What's negative x squared? What's a negative x times a negative x? Positive x squared. Minus 4 times negative x plus 4x plus 4. So now take out whatever you had in y2 and put in x squared plus 4x plus 4 into your y2. If we have negative y's, we make the y negative on the equation and then move it over, right? If we have negative x's, we make x's negative. That's it. Nothing crazy. So here it says, how does the graph of y equal f of negative? So this is a negative x. So it is a reflection in the, and we don't want to memorize, guys, because memorizing scares me a bit. It's a reflection in the, so if I make my x's negative, the ones that are positive are going to become negative, and the ones that are negative are going to become positive. So what axis am I reflecting in? The y, right? Like it makes sense. This is going to go over here, this is going to come over here, this is going to go over here, this is going to come over here. So it's a reflection in the opposite axis of what you think. So if it's a negative x, it's a reflection in the y-axis because I'm making my x's negative. So the negatives will become positive and the positive ones become negative, and you reflect in that y-axis. Oh wait. So the graph of y equals f of x is shown. Sketch the following reflections. So this is a reflection in the what? X-axis, because it's with the y, right? It's not affecting the x's. Do you see there's an x there? The x is just sitting there pretty. It ain't negative. So my mapping is going to be xy becomes x comma negative y. You see how it's not affecting the x there, right? Do we agree? Xy becomes x negative y because the y is negative here. And how do I know it's the y that's negative? It's not with the x. So now I take point by point and find my new point and connect them. But I work my way sequentially so I don't connect the wrong points together. So I'm going to go 1, 2, 3, 4, 5, 6. That's negative 6, 0. It's going to become negative 6, 0. So it stayed the same. But that's because this is going to stay the same. This is going to stay the same. And so is that. True? We're reflecting in the x-axis. So anything on the x-axis is remaining invariant. Because their y is 0. When I multiply by negative 1, it doesn't change. Let's do the other points. So this one is 1, 2, 3, 4, and 1, 2, 3, 4, 5, 6. So negative 4, 6. It's going to become negative 4, negative 6. So I'm using my mapping up here, the x negative y. So I drew it, and then I connect. Right? And then I go to my next one. It's at negative 1 and 6. It's going to become negative 1 and negative 6. The next one, I have this one staying, so it just goes to that. And then I have 1, 2, 3, 4, and -3. It's going to become 4 and -3, so 4 and 3. And then, does it look like it reflects in the x-axis? Like that's a mirror there? Yes. Then B, we have a -x. So our mapping is going to be x, y becomes -x, y. Because if it's in the bracket with the x, it affects the x in mapping. Correct? So, what is this a reflection in? If it's negating the x's, it's a reflection in the what? Y-axis. And the place that's going to be invariant is the y-axis. So I can go here right away and I can put a dot on it. That baby's staying for life, right? That's my invariant point. Do we agree? The one on the y-axis? Because its x value is 0. And if I negate a 0, it stays 0. So we're going to work sequentially again. -6, 0. -6, 0 is going to become negative a -6. So 6, 0. Then we have -4, 6. Is going to become 4, 6. And then I have -1, 6. Is going to become +1, 6. That connects to there. And then I have 4 and -3. It's going to become -4, -3. And then I have 7, 0. It's going to become -7, 0. And now if you look at the black and purple, they're reflecting in the y-axis. We agree? When you're done, flip over. So this one states, write the equation of the image given the following transformations, then state mapping. So this is a reflection in the y-axis. Let's think about it. In the y-axis. So what is being negated in order to go in the y-axis? X, right? It has to be here to go here, here to go here, here to go here. So our x is being negated, correct? So let's do it. You're welcome. Like that's it. Negate my x, right? For mapping, I also need to negate my x. So I'm going to get xy becomes -x, y. Right? Everyone writing that down? Then, for B, we have a reflection in the x-axis. Reflection in the x-axis. So here's my x-axis. I want to reflect in it. If I'm here, up here, I'm going to go down here. Or down here, I'm going to come up here. What's being negated when I reflect in the x-axis? My y's. So I need to make my y negative. Now, although this is correct, they often won't leave it as a negative y. They'll write it as a positive y. So what do? Divide both sides by -1. The negative does not go inside the radical. It stays in front. Because if it went inside the radical, it would be with the x, correct? And it can't be. And then once again, my y's are negative. In mapping. Six says y equals square root x minus 2. Is this a negative with the y or a negative with the x? It's with the y because the bracket has an x and there's nothing with it, correct? So I take my equation that they want me to find the new one for. I'm going to make my y negative. How do I move that? Divide by? Yeah, -1. And I can't put it under the radical, because if I put the -1 under the radical, what's my problem? It's with the x, and I don't want it with the x. So it's going to be y equals negative root x minus 2. Now what about this one with the negative x? It means I make every x what? Negative in the equation, correct? How many x's do I have in that equation? 1. So I'm going to go make it negative. Y equals, the catch though is that you have to make it negative. So you're going to go -1 x minus 2. Remember how I put the negative in front of the y? You have to put the negative in front of all of the x. Because there's a horizontal translation, it messes it up. Okay, then we're going to do this one and then we'll call it quits for the day. Equation is a reflection in the y-axis. What does it affect? X. So I'm going to go in here and I'm going to go y equals -x squared plus 1. What happens when I square a negative x? What the heck? The equation stayed the same. Well, this is a quadratic at 0, 1, symmetrical about the y-axis. So this graph actually looks like this. If I reflect that in the y, what's going to happen? It's going to stay the exact same graph, is it not? This arm is going to end up on this arm, and this arm is going to end up on that arm. So they stay the same. So people tell me everything's invariant if that's asked. No, it's not. This is the only thing that's invariant. That arm went on that one went on that one, right? But the equation is still going to end up being the exact same equation. And then a reflection in the x-axis affects the y's. So I'm going to get -y equals x squared plus 1. And I'm going to divide by -1 every term. So if there's more than one term on the right side, you divide every term by it. So we get y equals -x squared minus 1. And then that'll get you concave down, parabola, starting at -1. So it'll look like this, which is a reflection in the x-axis, right? So once you get your equation, if it doesn't have an f in it, you can plug it in your calculator to see if it works. Your homework tonight is to finish the homework from yesterday. And we're gonna do reflections and start stretches tomorrow, and we're gonna go through that quiz at the very beginning of class.
You definitely.